A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Salam sejahtera to everyone. Can you hear me, class? Hello, anyone?
Okay, doctor, I can hear you.
Yes, thank you. Thank you. Yeah. Syukur Alhamdulillah, we can meet again today, Monday, 22nd of November, 2021, or 17 Rabiul Akhir, 1443. Our class at 10 to 11, 1 hour class, 10 a.m. to 11 a.m. And we still in the middle of discussion talking about the balancing on the roto balancing. We completed the theory for the lecture yesterday and the day before yesterday. Yesterday and last week, the introduction. As for today, we're going to look for the tutorials. You can turn your book on page 112. We start with problem number 1. So let me change the screen now. I'm going to change the screen. I'm going to share with you this one. Okay, turn to page 112. And as I mentioned earlier, or perhaps in the very beginning of my lecture, most of the problems here is extracted from the past test and also exam. Yeah. The reason is why, because of course I do not put which semester and which year is that. Yeah, the reason is why, because I want you to feel the degree of difficultiness of the problem typically come out in the exam or primary test. So if you can solve this whole problem, inshallah, you will not face any problem typically in your test and also in your exam. So that is my intention. Of course, I'm not putting the years and also the semester. Okay, let's start with problem number 1. Excuse me. Again, my voice is not very clear, so very sorry if you can't catch word that I explain here clearly. You can ask me to explain again. Yeah. So in problem number 1 here, you have what? Oh, I forgot to. You hold on a bit. Yeah. I forgot to put my writing pad. Yeah. Sorry. Because I just finished meeting just now, so I basically not really prepared for your kids here. Give me a minute. I'm sorry about this.
It's okay, doctor, take your time.
Just sorry, because just finished my meeting just now. So everything in my table just to plug in the cable. So many cables here. So I can start writing. Yeah. Okay, Alhamdulillah. So we start with problem number 1. So as I explain how do you extract the data. You extract the data typically in solving the problem last meeting. So we are going to solve this one by here. Yeah, I'm going to solve by graphical. So I'm sorry for those who keen to solve by analytical. I have no ample of time to basically solve with that. So just make make the answer to be part of your reference if you keen to solve it with the analyticals. Okay, this is the one. So we are going to construct first is constructing table, and again table is compulsory table. So is a must. It's a must. Yeah. So this table is a must. Doesn't matter you start with which plane it doesn't matter. But table is must if you came to solving graphical. For analytical is an option. Yeah. So now I'm going to construct it. So what do I have here? I will start with here, this one. Remember, start with plane, then you have mass in kg, then you have radius, isn't it? That is in meter. You can also put in centimeter, doesn't matter. Yeah, you want to put meter or you want to put doesn't matter, it doesn't matter. At the end of the day, you need to make the unit consistent in meter. This one be the product of MR, which will give you kilogram meter. The next one is, let it put D here. Some will put meter. Yeah, D will be the distance from one plane to another. So this one put in another meter. Then put the MR, D. This one be kilogram meter, another meter. Or you can put it the kilogram meter square. And last but not least will be position, which is in degree. Huh? So plane, let's assume that you have a plane here, plane A. Then you start plane X. Then you have plane Y. Then you have plane D. You can also have plane A, plane B, X, it doesn't matter. Huh? I'm choosing this one as my convenient, as my convenient to solve the problem. Okay. M, it does mention about the M here. So because we are dealing with bearing, so there is no concern about mass for bearing. There is no concern about R for bearing, but you need to put here MR for A. Same thing for B, put it a B. So there is no mass, there is no bearing, so no radius. Even it is about not our concern to look at the or to define what be the mass and also the radius. So put it there the M B. Then you start selecting the reference. So yes, correct. Yeah. So start the selecting the reference. So the reference for this one will be A and B, right? So put it X. What does X? X, go back to the equation. They mentioned about X, add 1, then remove 1. So put it here. Add 1 is plus 1. This one put it here. M1 is equal to plus 1. The other one is M2 is equal to minus 1. Isn't it? So then you make a line here. You make a line here. You make a line here. Okay. Then the position as mentioned in the equation. What does the the radius is about 3 cm and 4 cm. So put it at 3, but it is 3 cm, isn't it? Look at here, 3 cm, 3 cm. So you have to make the units consistent. Put it as cm. This one is 3 cm, 3 cm, isn't it? 3 cm. The other one is 4 cm. Put it at 4 cm. And this one will be what is the position? It's 90 and 0 degrees. It's 90 here and 0. And the question provides us this one, provide this one. To make use of this reference, position reference, so put it there. This one, yeah, 0, 90. This one is 180. It is counterclockwise from your seat, horizontally. Start horizontally, counterclockwise. Then you have for y, for example, for what do you have for y here? Y you have also at y, you have 1 kg, another 1 kg, 3 and also 4. So put it here, 1 kg, put it M3, sorry, yes, correct, M3 plus 1, and for this is minus 1 at the position or at the radius of 3 and also 4. Put it at 3, another 3 here, another 4, the radius. Okay, and the position mentioned here is 270 and 180. So put it at 270, 180. This one is 270, that one is 180. Okay, so this is the parameter that you have to fill in. So the next one is start calculating or perhaps filling all the unknown parameter or all the blanks. Yeah. So this one will be theta A, this one will be theta B, which we do not know at the moment. And then we start selecting the reference plane. This is done as this is a part of your work in your first uh, uh, topics, which is on the adjustment. So it seems that this one is unknown. You have another one, this one also unknown, isn't it? So you can select one. So I'm going to select one as reference, put it there, reference. So this one becoming 0. So everyone be measured from A to the next one, to the next one. So for X, for example, is 1 meter. Let me bring it a bit. For X, yeah, for X is 1 meter. So put it there, 1 meter for X, a big one here. For Y, is another meter, isn't it? It's 2 meter, right? For B, I'm sorry. Astaghfirullahaladzim, I'm sorry. It's the wrong column, I'm sorry. Supposed to be here, isn't it? Supposed to be. Then 2. The next one is 3. For B, we put it at 3 meter. Okay, now this is where you have to ensure that what you done is correct. Because why? 1 Newton is in centimeter. This is very typical, question, or very typical, what do you call it? Yeah, very typical linguistic done by the student. They put it in centimeter. This one they put it in meter. So very difficult. You have this one centimeter meter. So make sure that you use what? Same or perhaps consistent units. Okay. So now, if you want to put this one in centimeter, for example, or in meter, for example, so what do you have here? You multiply by 100, isn't it? Yes or no? Yes or no? So now, we put this one all in meters. That's it. I mentioned that you have two basically things. So this one is 3 centimeter. It's about 0 0.03, 0 0.04, 0 0.03, 0 0.04. So now we change it becoming meter. So it is correct, but this one here, you will have kilogram, centimeter, meter. Then you forgot to divide it by 100, and very serious about this one because you have a very different unit. So make sure that unit is consistent. Yeah. So now you add up to get also you get product here. So you have 0 0.03, and this one is 0 0.04. And this one, yeah, MR1, MR2. But remember again, this one, remember again, we have plus and minus, isn't it? You saw this one is plus. Oh, let me put another color so that you can differentiate. Green color is nice. Black color is nice. This one is positive. This one is negative. Isn't it? Correct now? I purposely sometimes not do this one in the beginning, yeah, because I want to ensure that you follow my lecture. Okay, same thing to this one, so it become positive here, 0 0.0 Astaghfirullahaladzim, I do this one correct, that's correct. This one is not correct. It's not correct, isn't it? This one is 0 0.3, this one is 0 0.3, this one is 0 point, not correct. Yeah? This is now is correct. 0 point, this one what? 0 point, 0 point, B. This one is 0 0.04. Now it's correct, correct? Now you have 0 here. We have this one. Okay, this one is, you will have here, excuse me, we have here positive 0.03, negative 0.04. This one is positive 0.06, negative 0.08. Correct? Then we have B, M, R, P. And we do not know what be the position. We also do not know what be the position. So now tell me, do you agree with me or not? Or do you understand this one, how I'm selecting or perhaps do all the product of the table? Yes or no? It's not very difficult, isn't it? It's not very difficult, yeah? So now, the next thing is, thank you, Aisha. The next thing will be how I'm going to construct or plan to construct the polygon. Look at here. So you have two polygon now. One polygon is the MR versus theta. We call it this one as cos polygon. In the exam, you don't have to do this one. Yeah, this one is a part of your theory notes. Yeah, MRD versus theta, and we call this one as a couple polygon or moment polygon. Some call couple, some moment is the same. Yeah. Okay. So now, so if you construct this one, you have two unknown. This unknown, this one also unknown. So which, you can't do that, isn't it? So we start with this one, polygon number one, polygon number. Okay. So now start construct polygon MRD versus theta, which we found that the you don't this one, yeah, the boundary condition comply this one equal to 0, meaning that the polygon is a close one. It's a close. Okay, then start construct. Very difficult to construct because I need to do another to make another blank. Blank. This one. What I have now. Again, the pull down menu is disturbed by. I cannot hide the pull down menu. No idea how. Okay, never mind. I'm going to use this one as part of my polygon. So construct this guy, this one, and this one. Okay. So now construct the polygon. What you have? You have 0.03 following this one, following this one. 0.03 90 degrees. So pointing upward. So 90 degrees, this one, pointing upward. Pointing outward, yeah, 90 degrees pointing outward. Okay. I'll stop in this one. Pointing upward, 0.01. So the next one, sorry, it's not 0.01, it's 0.03, guys. Sorry. My mind is not basically tuned to your class, 0.03. The next one is 0.04, 0 degrees. Isn't it? So 0 degrees will be pointing toward your right, 0 degrees. 0.04 degrees. Remember this one? 0, 90, 80, 270. So toward your right. So the next thing will be, what do we have? 0.06, 270, and 270, pointing downward. This one, 0.06, 0.06, 270. Okay. So the next one you have 0.08, 180. 180 will be pointing. 180 will be pointing. 180, isn't it? Pointing here, so it will be pointing the other way around. So you will have.
Sorry,
Sorry, we move.
Is that
Where do I get wrong?
the 0 degree, the negative 0.04, right?
This one is correct. So we have 0.08, correct. This one is
And
correct, 90. It's up. Oh, sorry. Thank you. This one's supposed to be 0 degrees. Thank you. So the 0B will be, let me clear the whole thing. Thank you. Yeah, thank you. I put the wrong direction, am I correct? So this one, yeah, this is correct, 90 degrees. So you put this one, 90 degrees. Start at the middle. It's easy for us. 90 degrees, 0.03. The next one we want to have, you have 0.8 is 0 degrees, isn't it? But now 0 degrees here, but negative pointing to 180, so pointing to this one. So I'm going to clear this one because my polygon went out of my paper, out of screen, yeah. So I need to do this one, put it in the middle, easy. .04. The reason is why it's basically 0 degrees, correct? Pointing your right, but you have negative here. So it will not pointing 80, but instead be pointing 180. Because negative will tell you the opposite direction. Eh? So the next one is 0.0.6 pointing downward. Okay, 0.06 pointing downward. Pointing downward is 0.06. So the next thing you have is 0.08 negative, and it is 180. It's supposed to be fall to your left, but you have negative here, will fall to your right and fall at 0 degrees. So you will pointing that way with 0.08. 0.08. And it is not a closed polygon, but you know that you have to follow the one? Follow this one. This is the boundary condition saying that polygon constructed by the couple must be a closed polygon. So you force yourself to close the polygon. Okay. So this one is not very difficult. You can measure, you can also calculate. Isn't it? If you calculate here, this one be, let's see this one in scale, yeah. This will 0.6, this one will be 0.3. This one 0.4, this one 0.4, this one be 0. This one be 0.0. Yes or no? So therefore, what we're going to look for just now is dynamic forces. So dynamic on bearing is, you will have, okay, before that, yeah, class, you need to measure what be the angle. So the measurement must be done here, following this one counterclockwise from the horizontal. So you measure this one at tail. Get it, theta, what theta unbalanced. Okay, so start this one. So now, so therefore, you have the F. This one will be, the column is belong to P here. So you calculate this one, the last line, yeah, the last line will give you MRD here. Excuse me, MRD unbalanced is equal to, go back to this one, you have 3 MRP here. So you put it here, is 0.05 is equal to 3 MRP. Then so therefore you will have here is MR for B is basically 0.05 divided by 3 with the unit of kilogram meter. And in calculation, to define the dynamic force in bearing, you have what? FB is equal to the MRB omega square. So you will have here 0.05 divided by 3 multiplied by 2 pi, and the speed given here is 500 RPM. So put it here 500, we have multiplied by 500 divided by 60 square, then you will have this one. The results is in Newton. I don't have a numbers here. I don't have the the answer here. Okay, so that is one. This is the magnitude. Remember, this one is magnitude. You need another one is position, because you are dealing with vectors. So the position is, you need to look for this one. You need theta, this theta, small theta, put it there, small theta here. So that is, you can use as one You can use sine, you can use cosine, you can use tangent. Am I correct or not? If you're keen to use tangent, for example, yeah, tangent theta is equal to what tangent to us? Opposite 0.03 divided by anyone? No one interested to respond? Divided by 0.04. Thank you, Nani. So you have theta equal to what you get, Nani? If 0.3 this one, arctangent, theta will be, what is the arctangent 0.75? Anyone? Anyone? 36, 30, make it 37, yeah, man. Thank you, yeah. Because I don't have calculator, I need your cooperation here, 37. So this is 37. Let me clear this one, yeah, so that you can understand. Let me clear about this one. Then this is 37. 30, let me also use another color so you can easy to differentiate, isn't it? 37. So this one is 180. You need this one, right? You need this one. So we have 180. 180 minus by 37 equal to 1, what? 1. Anyone? I just want your response. I can calculate basically 143. Thank you, Tan. 146 is 143. So this 143 is your unbalanced. So you put it there 143. So you go back to the this table, clear this one, that will give you 1 4 3. This one is 1, is 1 equal to 143 degrees. Okay, then you go back to your calculation, this one. So you need the direction, right? So you take the last line, taking consideration of the last line, this one, which is now is 143 just now, and this one is 37, and this one is FB equal to, could anyone tell me what you have, what do you have here? I don't have a numbers here. Could anyone tell me? Anyone keen to respond? Otherwise I just put FB on here. No?
45.7.
Sorry, can you write? Because the line is not so good, yeah. Your 45.7, thank you, yeah. 45.7, 45.7, thank you. So this one is the FB. This one on what? This one is dynamic force, correct? This is dynamic force. But the dynamic force acting on where? On where? On where? The 45.7 with the direction of 143 degrees, measured from the horizontal rotating counterclockwise, and measured is the dynamic force on where? Anyone? On where, class? Let's make the class active, yeah. Thank you, Sharp, on Sharp. And this is not our concern, correct? Because the equation asking, you go back to the equation, it's asking about all on bearing, put it the all bearing, so on and so forth. So you need to inverse the direction. So inverse the direction, or make it opposite. I'm changing the color here, so make it opposite. This one. So this one is also FB is equal to 45.7, but the angle is 37, or perhaps can put here as 680, 83. Sorry, it's not 83, it's a 53. It's 53. So both. So this is on bearing. So this is the result. Bearing where? Bearing B. Okay? Okay, now we move to the next one. Any question up to here? Yeah. Okay, we'll move to the next one. We are going to construct another table, yeah, and sorry, another polygon. The polygon of what they call it, the polygon of force now. So I'm going to open up another one, another file. Okay. Okay, now we have a blank now. So constructing the MRD polygon. So now polygon, this writing pad is giving problem. Polygon, yeah. So your summation of MR equal to 0. So we should have the MR versus theta. So you construct this one, yeah. Make it okay. Construct this one. Let me put another color. This one now. We are going to construct this one versus this one. Okay. So you have 0.03 90 degrees. Okay, now 0.3 90 degrees and 90 degrees pointing upwards. So again, this is our reference. 180 to 70. Put it just start at the middle, easy. Starting point 0.090 degrees. 0.0. Next, negative 0.04, 0 degrees. It's supposed to fall at here, but negative you fall here. 0.04. 0.0. Next, you have 0.0.3, 270, and 270 is pointing downward. So it will basically same length, 0.03. Next, you have 0.04 negative 180, and 180 is supposed to be pointing to left, but you have negative is pointing to here. Then you found this one 0.4, and it's a closed polygon, isn't it? But not to forget that you have another parameter, which is this one, this MRD just now. This one, yeah, this one, put it here. You have that one. This one, put it here. Okay, 3 RB. So the what do you have for RB just now? RB just now is 0. 0.3 divided by 3, isn't it? So you put it here. You put it here. The MRB you have 0.05 divided by 3. Am I correct? Yes or no? So this one is 0.3 divided by 3. So you put it here. At the theta B is equal to 143 just now measured by our friend. So we'll be pointing this one this way. This one is 143 degrees. End up here with 0.05 divided by 3. Yes or no? Yes or no? Anyone respond? Do you understand in class? Hello? No one, want to entertain me. Why are you crying just now? Understand? Thank you, Tan. Okay, now. Thank you, Aisha. Okay, now it is now again. It is not balanced, right? So how to balance it? Is to balance it to bring back the line, and the line must be formed at the starting point. This is your starting point. Starting point. So you bring the line, and the line will fall at the same place. So this one will give you the M unbalanced is equal to 0.05 divided by 3. The units of kilogram meter. Right? But now it is pointing downward, pointing downward. Then you measure this one, measure this one back. Yes, Nani, speak up, Nani. I basically can't catch all the the equation in your why the pointing upward and pointing downward just now. Yes, Nani, speak up, Nani. I'm waiting for a response, Nani. Nani.
Yes, doctor.
Yes, which part you do not understand?
The 0.06 earlier. If we see it based on the positive or negative, why it's acting downward, not upward?
Are you talking about this one?
No,
This one? Which one?
the 0.06 earlier.
Oh, just now.
Yeah.
Oh, not this one. Okay, come back. Never mind. Come back to here. Okay, this one, yeah. Okay, the reason is why. Let me check. First we have to go back to the data. 0.06 is 270. This one is this one. Let me put another color so that you can see. Yeah, 0.06 here at 270, isn't it? And the 270 is pointing downward. Correct? This one. Yes or no? Yes or no?
Yes.
So that is
Yes.
why this one is also pointing downward. Okay. I'm
But
going to say
0.04?
0 point.
But 0.04? Why to
Okay,
the
okay.
left?
Look at here.
Correct?
0.04. Look at here. They focus on this one. Let me clear about this one. Let me clear this one. Okay. Never mind. Never mind. Okay. Take another color. Okay. Now, this one is negative 0.04. Correct or not? This one
Yes.
negative, isn't it? Okay. Now, 0.4 is 0 degrees. Okay, put it here. Okay, this one, yeah. 0.04 and negative, yeah, and 0 degrees. So you have, where is your 0 degrees? This one correct. This one is 90. This one is 180. This one is 270. Correct. So it's supposed to be fall here. I agree with you. But when we have negative, it will not fall at, will not find at 0 degree. It will fall at 180. So you have 0.04 and 180. Agree on?
Agree. But 0.06 is positive, right?
Yes. It is positive, and the 270 is pointing downward. Am I correct or not?
Yes.
So which one you do not understand? This
Mm.
is 270 pointing downward, so it'll be pointing downward because 270 is pointing downward. So this one is 0.06. If you found that this one is not positive, yeah, it is instead it's negative, so it will not be pointing downward, it will be pointing outward. It's always opposite when you have a negative.
Oh, I see. Okay, okay.
Okay, it's always negative. You know, just remember that if your negative sign is always opposite from what you have. Okay, I hope
Okay.
you can understand the one. Yeah. So let us now move to the this one. So we completed this one. So we found that this FA is equal to the M of A multiplied by the omega square, and we found that you will be getting the same result from the previous one multiplied by 500 divided by 60, where you will have what we have just now, yeah, 45.7. You have 45.7 Newton. It's 45.7 Newton. And the position now as what you not as what you have here. This one you have to measure. You have to measure, and you can also calculate. Okay, now let me how to get theta A. Easy, right? Okay, how to get theta A? You can measure or use calculation. You measure or use calculation. How is it? Look at the theta A, yeah? Okay. We have, okay, now put it in the last line of theta A. This one is, remember this one, the last line, this one is M arm unbalanced is equal to the M arm A now. So you've been need to know what this one, correct? So this one is theta unbalanced is equal to theta A. Yes or no? Put it this one. I'm zooming in this one. Okay, and you already calculated earlier. You already calculated earlier this one. Earlier, yeah, is 143 degrees equal to theta p. Am I correct or not? So this one becoming 37. Yes or no? Because this one is also 30. Oh, sorry, different plane. This one is 37. This one is also 37. Correct. So if you want to calculate this one, you have to what? If this one is 37, this one is 53. So you have 270 plus 53. That will be the angle for theta A. Any argument on that? Correct or not? Correct or not? No. Plus, anyone respond? Yes. Okay. Thank you, Nania. So this one, so you will have, what do you have here? You will have 3, 2, 3 degrees. So this one you have to put in the table. Put it in the table. 3, 2. Sorry, the table is the other file. Huh? This one be 3, 2, 3 degrees. So that will be the completion of. Sorry, astaghfirullah. This one is supposed to be here. So that is the completion of your table. So the next one is to calculate the force. You have take the last line here. Take the last line. Always take the last line. Yeah. Always consider the last line. So the takes last line now. You have FB. You calculated FB as 147.5 degrees just now. Okay. So the position will be, take the last line. This one is FB equal to 47.5. This one you calculated just now is 3 to 3 degrees. This one is 37. This one now becoming 37 also. So this one is on shaft. Agree or not? This one be on bearing. So the on bearing one, you will have, take another color. Put it this one on bearing. Zap. Same magnitudes. FB equal to 47.5 on bearing. This one on shaft. Understand now, class? So that is the first part of your equation. The first part, only the first part. Now we completed the first part only. So the second part is talking about total force on bearing. So when you're talking about total force, now total force, remember when you're talking about total force, it's basically coming from statics and also dynamic. The dynamic one completed. This one done. So you have to focus on static. Okay. How are you going to static? You go back here and you have to do the free body diagram. So if I can share with you the 4D diagram, so static analysis. Yeah. Shaft. Go back to this one. It's correct now. Isn't it? A and B, put it here, R, B and B. This one is R, A, R, B. You have two discs pointing downward, MG, MG. It should be MG, this one. And if I can clear this thing. So if I may say that this one is X and Y, so you put it there, this one is X. This one is X, this one is Y. So remember, when we are doing the analysis, static analysis, this one, the mass must be what? Must be what? Who can remember? Must be what after? Must be after? After? Must be after? Modification. Thank you, Tanya. Must be after modification. So, but here very fortunate, yeah, because they provide you what, 10 kg, plus 1 kg, minus back 1 kg. So basically, it comes to the 10 kg here by 9.81. Same thing happened for this y. But in conclusion for the theory, must be after modification. Whatever you have, this one must be after modification. The reason is why when you add and when you add take away, you add and take away, you found that the final mass will be the mass that the bearing will be supporting. Remember that in theory, yeah, you have to understand that after you add mass, you know, you lost, you remove mass, you add mass. So the last mass or the final mass must be the mass that supported by the bearing. Okay, now you do this one as usual. Apply summation of at a equal to, saying this one equal to 0. So you will have here, okay, 9, 10, 9.81. This one all 1 meter, sorry, all 1 meter, away by 1 meter. It's very easy now. This one is plus, we have another one, 10, 9.81 multiplied by 2 is equal to RB multiplied by 3. Correct? So you will have here 10, 1 more minute, sir. Okay, sorry. I know that you have another class, so you will have. Can you give me what will be the numbers here? So we will continue this one the day after tomorrow. Yeah, this one is Newton. And the other problem or the other equation will be sorry, astaghfirullah. The other equation will be you have Fy equal to 0. So we have RE plus RB must be equal to 9.81. This one by 20. Okay. So you will find so I will stop here. So the next one, the next meeting, inshallah, on Wednesday, we will try to complete the whole thing. Yeah, just remind me with two things. One will be this one, the completion of the problem number 1. The other one will be what are the topic, because yesterday we have a meeting about the topic come out in the exam or in the test. So what are the topic in the test, so that you can focus on the topic. The reason is I display or I disclose the topic in the test because this is about OBE. OBE tell you about what is the outcome based education. The outcome meaning that base education is you've been adequate in the online system or learning. So that the thing that we are going to evaluate you. So we have to let you know up to where that you study in the class or perhaps in the online session. Okay, till then I hope you have no problem with that. So I will see you inshallah on Wednesday. So with that, I would like to end my session with Assalamualaikum warahmatullahi wabarakatuh. Stay, stay healthy, stay safe, and also stay study. Thank you, class.